I think I'm ready. Let's see. I'm going to need gloves on, and I'm going to try to pull off somewhat of a repair video today. There's been a lot of you asking how these repair videos are put together. Maybe one day I'll do somewhat of a video on that, but for now I just have to really keep the repairs moving. And also, I want to say before I get started, for all of you people who are hell-bent on wearing these little static straps around your wrists and stuff to deal with static electricity, all you have to do is put on one of these damn earphones. And every time you stand up out of your chair, whenever your ass separates from your seat, it develops this opposing charge to where you're charged at this potential, your seat winds up charged at the opposite potential, and then when you turn around and touch something, kapow, you get a static charge. So static is actually caused whenever two materials of dissimilarity part ways, and whenever they part ways, they take on opposing charges. So what this means, I'm scared to death. What this means for me is that in the wintertime, whenever it's excruciatingly dry, I stand up out of my chair. Let's see if I can do it. Hang on, I'm so scared. I'm scared to do it. I'm not going to do it. I'm just not. I'm not going to do it. So what that means for me is I am wearing an earpiece that in its cable has a grounded shielding that goes all the way back to my computer tower. And then from the computer tower is hooked to the Earth's ground, and it provides a nice little pathway to ground so that whenever I stand up out of my chair, kapop, I get a static shock out of my earpiece into my ear canal, and I hate winter. So let's move on with this repair. This is an iPhone 6 that originally came here for a backlight repair. A lot of these boards are mildly long screw damage. This one's a little bit more than mild, but it's not damaged in such a way that I would think that it would cause any issues. So I looked at it and yeah, it does have some long screw damage, but look, FL 2024 is smoked. So quick little backlight filter replacement on this one. The board boots up, but shortly after it begins booting, the board starts to heat up and it draws too much current and it gets hot. It gets really, really, really hot. So what we're going to do here today, this guy is asking me, hey, what's up with my phone? Dude, I'm really sorry, but this one got complicated. I'm going to see why this board gets hot and exactly what it is that we're getting into. So the first thing I'm going to do, I'm going to try not to get up out of my damn chair or I'm going to get shocked in my ear canal. All right, maybe I'll get a static strap. That way I'll get shocked in my wrist every time I stand up instead of my damn ear canal. I'm going to switch you over to the microscope so that you can see the finest of screw holes. I know most of you are watching this channel because I talk about screw holes on a regular basis. Now, this is really nasty. I mean, the board itself has a grungy look. This screw hole damage here is fairly ugly, but the phone boots with image and the board's not pulled apart. So I'm going to say that chestnut enable, LCM resets, okay, those traces are fine inside of this screw hole. Now we're going to get over to the other one here. What I'm really doing is testing to see if this video gets flagged because I say screw hole. And this bottom right screw hole, it is punctured almost all the way through, but this board boots, so I don't think we have an I2C line shorted to ground. And let's get on over here to the middle screw hole. This one is punctured all the way through. This middle screw hole is awful. Now the middle screw hole, the trace under it that we're mainly concerned with is PP1V8. PP1V8 travels under the middle screw hole, and it travels under the middle screw hole, I believe, on its way over to the display connector. Well, the filter at the display connector, and that's where the display connector gets its sauce. You know, the trace under that, don't listen to all that. The trace under that screw hole is really fat, so it might be feeding other stuff. But either way, whenever there's severe middle hole screw hole damage, you wind up with a phone that also has no image, and if 1V8 shorted to ground, I would imagine that the board won't boot. So, you've seen what the screw hole looks like. I will show you my beloved backlight filter. There is FL 2024, just is gorgeous. It's marvelous. And let's see, what are we going to do now? Now we're going to hook this up to a power supply, and I'm going to show you what the current draw does here so that we get a little bit of a control test here so you can see what there is to see. So we're going to hook our green one up, which I like that this probe here has the ends color coded because that saves me. What the hell? I got to get a wired keyboard. Saves me quite a bit of time. So here we are. There's my little pile of my last job laying there. We're going to hook this up to the supply. And let's see, right now my supply is set to where you can see the current. I'm going to turn this on so that we can see current over time, and I'm going to trigger this phone to boot. So as you can see right now, our current is at 0 and our voltage there, since it's not written on the screen, I will tell you that the voltage is set to 4.2 volts and we are drawing 0 amps. And I'm going to go ahead and prompt this thing to boot. We get 90 milliamps. It does make me a little nervous at how long it hangs here at 90 milliamps. Is all my mouthing about the bottom right hole, screw hole, inaccurate? All right, we are now drawing 200 milliamps, 300, 400. I wonder if I can adjust my scale on this thing. Okay, this thing is now drawing a full amp of current. So I believe the way this works on your screen is the 1, 2, 3 over at the right is current. And then the 0, 10, 20, 30 at the left is voltage, of course. And you can see how our current is kind of, this looks like normal boot. It's fluctuating between 0 and an amp, but at some point in time during the boot process here, and this is the first time I've done this with the wave display on this supply, so I'm feeling for the board to start getting hot. It's not doing it. What the? Well, this appears to be completely, totally normal. I'm going to switch this back over so that you can see the actual numbers, because that's what most people are after. Okay, well, this board appears to be drawing complete and utter normal current now. I don't see anything. I don't see anything wrong with it. Wow. Well, maybe that's what I should do from now on, is just try to record the repair and everything will be fine. Okay, I'm going to shut DC power off to this thing, and I'm going to go ahead now. I'm going to drop this back into this housing, which maybe it's the housing. I mean, look at this housing. It's rough. It's it's a typical iPhone 6 housing, all mutilated and warped. This one I almost backed out on account of appearance, but it was, in all reality, a blown backlight filter. I've fixed a lot of bent up, nasty looking stuff, and it only winds up, it's some of it winds up being okay. So, all right, here we are back in our original housing. I'm going to go ahead and plug a test screen on. There we are. Very nice test screen there. And we're going to hook our... What am I on the wrong mode? I'm going to look like a dummy. I've been trying to adjust my new power supply, which, guys, I got to say, I absolutely, completely love this new supply, but the software that comes with it leaves a lot to be desired. You only get about 60 seconds of graph on the screen before it erases and writes back over. So maybe one day I'll get around to tinkering and figure out if there's something else I can do with the software on this thing. So let's see. If we turn our... There's our DC supply the way it's supposed to look. Why did it look all wonky before? Was I on my hands view? That's why, because I created two different croppings, one to crop out the wave view and one to crop out just the amperage view. So there we are on amperage view. I am going to go ahead and hook my supply up, which, by the way, when the supply is off, this software will show you what the amperage is set to rather than what it is actually pulling. So now we have our DC supply turned on. We're at 4.2 volts. I'm going to go ahead and push the power button and let this thing boot. Okay, so we're drawing 160 milliamps. 180. And once again, all I've done here is replace the backlight filter, FL2024, and I did it without hot air. For anybody that's about to say, you messed something, I did not mess anything up. So let's go ahead and move on. Dun, dun, dun. All right, we're pulling an amp. Are we getting there? 1.17. We are getting heavier than normal. Are we getting heavier than normal load? I put this thing back together and it got hotter than a firecracker. I put this thing back together and it got hotter than a firecracker. And now we're hanging around an amp. I mean, we were talking 1.5 amps, 1.7 amps, you know, way, way, way too high. Now, all I've done is take this board out of the housing. And it's no longer drawing this massive load. Okay, well, I'm going to try to turn this so that you can't see everything that's on the screen. We're going to unlock it. And I forgot to mention also Wi-Fi was disabled, so I was concerned maybe it's a shorted Wi-Fi IC. Let's see if Wi-Fi is working now. No, Wi-Fi still won't let us enable. But it's pulling an acceptable load, though. I mean, that's completely acceptable. Man, this thing sure did get hot. Let's have a look at this screw hole again. I'm going to leave the phone on. I mean, this is cut deep, but let's see if it'll move. I mean, if I can get away with not fixing long screw damage, I'm going to do that. Yeah, it's not. This isn't pulled apart. But you can see the shield's been cracked loose. The traces here for Wi-Fi, they're out here on the outer edge of the board. So if the screw hole hasn't been pulled loose, I'm really not inclined to think that this is being caused by long screw damage. I would expect before we had issues with Wi-Fi, we would have issues with image. And the phone boots and works fine. How's our current doing? I don't see anything wrong with this phone, other than the fact that it does not get Wi-Fi. Let's see. Okay, I'm going to pull the power supply off of it. And we are going to now have a look at the back side of the board again. Now, keep in mind how bent this housing is. I mean, yeah, long screw damage can cause Wi-Fi issues. This thing was getting hot, man. It's not getting hot now. We've got this fold on our sticker. I don't know if you can see that or not. Let's see if I can get it lined up. There's a crease that goes across the sticker this way. Right across here. And I don't know why that's there. If you do look at the housing, you see it's considerably bent. I don't want to dig in on a repair here that's going to eat up a bunch of my time and not have any success. Long screw damage, bottom left hole, yeah, could be causing Wi-Fi problems. But by the time I cut into this and look at it and I wind up reconnecting all the shit for image and flash as well, and then it's not the cause of the Wi-Fi problem, then I've just wasted a whole bunch of time. So I'm going to see if I can tell what is truly wrong with the Wi-Fi on this. Let's go ahead and remove the back sticker. I'm going to heat this board up just a little bit in hopes of doing this cleanly. Yeah, I have not been having an issue with getting shocked in my ear canal until today. And today it happened once and made me a little paranoid, but then it happened again and it gave me a double pop. And now I'm really paranoid. So you're not going to see me standing up out of this stool real fast with this headset in. You know, a lot of people got misconceptions about static electricity. You roll up to the gas pumps and you read the thing when you're getting ready to pump fuel and it's like, turn off the motor, turn off your cell phones. And it's like, no electronics. And it's like, who's writing these rules? I would think that people that are designing this stuff would have a real good conception as to where static electricity comes from. Whenever you get out of your car and you turn around and touch the car and you get pow, That pop, that is coming from your ass leaving the seat. The car is running around, you're up on rubber, you're charged anyway. And what happens whenever you separate yourself from that charge, you're charged with the car. And whenever you pull yourself away from that charge, you and the car take on opposing charges. You're now charged at an opposite potential from the car, and you turn around and pop, static electricity. So whenever you're getting shocked in the wintertime and you get out of your car, it's not because your cell phone's on. It's because of your ass leaving the seat. So I got sidetracked. I was warming up this board, right? I don't know. I'm excited to be recording a video. I kind of feel crappy because this thing's not acting up. I mean, I did have a solid path to follow. I had like 1.7 amps and it was getting really, really hot. I wonder if this could be a short at the middle screw hole at PP1V8. But I would think if 1V8... Oh, I'm not hot. I would think if 1V8 was shorted, this phone would not boot. It wouldn't like boot and then just sit there and get hot. So right now, my feeling is that the Wi-Fi being grayed out, combined with the symptoms that I had of getting hot, I feel like that is all caused by something to do with this bend. I don't feel that is long screw damage. It might be, because the damage is looking pretty bad. I mean, it looks really bad, but I didn't do a very good job on that now, did I? I didn't heat it that hot. This board is looking like fluxy, liquidy. What am I even looking at? Ow! Note to self, turn that down and get a static strap. What is on these components? Have we been getting hot? I mean, the board got really, really hot. Did we get hot underneath? What am I looking at? What is that? I'm reasonably certain that that's a dead animal. Let's see if I can get this in view for you. All right, let's extract the dead animal from this phone. Well, the dead animal fell apart in pieces. So, that's likely not the cause. Let's see if we can get its head out of here. Let's poke its head out under the shield. And you gotta figure what size animal this is if I can fit it out of the crack in the side of this phone here. Ugh, some kind of an insect that's way down in there. All right, let's blow that out with air, because I'm not going to spend any more time digging for it. All right, so this phone has grayed out Wi-Fi and it gets hot. So I'm going to go ahead, let's see, we're going to check this little, first of all, let's check and see if there's any cracks in the underfill. I don't see anything obvious. A lot of times cracks in the underfill are an indication that the Wi-Fi IC has been yanked. I've known this cap here to get shorted and cause no Wi-Fi. Let's go ahead and check that for shorts. And I'm probably going to cut this one short because the intermittent no Wi-Fi behavior is, well, no, the intermittent getting hot behavior for this thing might be a very, very nasty problem to track down. And I've got a busy day ahead of me today. Let's go ahead and see if we can get our meter working, because it's not working now. Motherfucker. We're going to COM set, COM 14, did not work. Try COM 1, did not work. All right, let's go back to COM 14. Did not work, and I give up. That means I've got something that's changed on USB, and for the sake of keeping this moving, I'm just going to have you take my word for it. So right now we are at 0 ohms. I'm going to check both sides of this cap. We got 2.8 ohms to ground on this side. 2.2, wait a minute, what, am I checking the wrong? No, that cap is shorted, or we have a short here. So we have 2.2 ohms to ground on this side. Gosh, I wonder why my meter don't show up. I should probably fix that so that you can see it. No, you know what? I'm going to keep this moving. I need to fix this phone. So we were getting hot intermittently, no Wi-Fi. One side of that cap is at 2.1 ohms. The middle of that cap is at 1 ohms. The middle is ground, I believe, and the outside is at 2 ohms. So I am going to go ahead. I'm going to open up ZXW tool for you here, and we're going to look and see exactly what this line is responsible for. And then I'm going to blast this little prick with some hot air, and I'm going to change it because I need to move on. I am really concerned about the appearance of this phone, but even if this winds up being a no fix, I can at least send it back in a way that it's not going to get smokingly hot. To be honest, when I started this video, I thought that this was going to be a shorted Wi-Fi IC, which I have not been fixing. I'm sure there's others that are. I have not. And I was going to show how that we could disable that shorted Wi-Fi IC without prying it from the board so that the phone could actually be booted up and survive a data recovery. But we're not going to do that right now. Let's go ahead. Let's get onto the back of the board. Let's zoom in on that little dude. And we've got C5201. Okay, it's C5201 RF. Gosh, I'm going to try not to sound like a dum-dum. Dum-dum. I don't care if I sound dumb. Not today, guys. I just don't. So one side of that is hooked to the Wi-Fi IC, and the other side of that gets fed through this inductor here. Is it actually C5201 RF that it's shorted? If it is, it's going to be like a... I guess we could remove this inductor. Let's see what this does in the circuit. Let's pull up C5201 RF on the iPhone 6 schematics. I'm going to open up Blackfish here. Man, I am repair video rusty, guys. But one thing I know is I can't record with more than one file right now. I can't. I got to keep stuff moving. So let's look at the iPhone 6. Give me an error. I'm taking you out in the yard. I'm dumping gas on you and burning you. All right, C5201 RF. Let's see what C5201 RF is. Okay. Now, if you do happen to have a shorted Wi-Fi chip and you've got an iPhone 6 that gets really, really, really hot, keep in mind that you can remove L5201 RF, and I believe that's how I've done that. I've only done it to one in the past. But if you remove L5201 RF, it puts this chip in a state. Now, if it's got a VCC main short, forget about it. VCC main is here, right? Yeah. So if you've got a VCC main short inside of your Wi-Fi IC, forget about it. You know, remove the IC. But if you've got an IC that doesn't get hot immediately and it gets hot later on during the boot sequence, you can remove L5201 RF, and it prevents this IC from powering on and prevents this IC from getting hot. So, since we have, over here, we've got C5201 RF, you can see that the only thing on this line is C5201 RF. We have nothing else on this line that would give us a path to ground unless it's the Wi-Fi IC itself. So if it's the IC itself and we remove C5201 RF, we'll still have a short. But if it's C5201 RF and we remove it, we'll no longer have a short. So let's go ahead and heat our hot air up. And also, I mean, you could remove this inductor as well to see if there's a short, you know, on which side the short is. But I'm going to say if we remove C5201 RF and this line is still shorted, either one of these lines is still shorted, that means our short is internal to the Wi-Fi IC, because L5201RF doesn't have a path to ground. C5201RF is the only component on this line that has a path to ground except for the IC itself. So if we remove C5201 and we still have a short, that means the short is inside the IC itself. Why it didn't get hot this last time that I booted it, who knows? Who knows? Let's move on with this repair. I am going to go ahead and act like I know how to fix phones, because the last few days it's felt like I don't. And what is going to be our best method to remove this? I am going to go ahead, I'm going to use hot air entirely. I'm going to come in, let's see, I want to blow my hot air away from the IC, the Wi-Fi IC. And to be extra safe, I'm going to put a little bit of a shield over the Wi-Fi IC. Now watch, now that I've heated this board up, then the long screw damage is going to come back to screw me. All right, we're going to start heating this up. My air is at 350C. My flow is at 40. I'm going to trim around this. And I will say my nerves have been especially bad today. My nerves this morning have been causing me to question how things are going to be in the next few years. You know, I keep expecting as I get older for things to get better, but in terms of my nerves and my little bit of jitters that I have from time to time, that seems to be getting worse. All right, do we have this in the view here? Let's zoom in a little bit so maybe you can have it a little clearer. We're going to add a little bit of flux to this. And we're going to start heating this up. This is not a part that I stock, so I'm going to take this off. I'm going to see if we have a short. If the short's gone, then I'm going to need to grab this off of a donor board. Okay, there we go. This should be the kill. There it is. Now right away, while this board is still hot, I'm going to get some leaded solder in here. We're going to put a little more flux on here. I'm going to take my 2032 micro pencil with the 0.1 millimeter conical tip, and I'm going to keep our board warm a bit here, and I'm going to take this blob of solder and I'm going to bump these pads. I don't like how that turned out, so now I'm actually going to add a little bit more flux. Make sure everybody's shiny, because if the board is now not shorted, then I am going to go ahead, I'm going to replace that component. I don't know, I might leave the majority of this video unedited. I've got some screw-ups there trying to get my power supply and stuff to work, but I think people like to see the bloopers. Alright, I've got my black probe on ground. I'm putting my red probe on one of our sides of that cap. And we get 7,000 ohms on that side. And on this side, let's do that again without my probe touching the shield. That side we get 30,000 ohms. And if you don't believe me, you know, whatever. I don't care. Maybe my next repair video I'll do it with the meter working. I would honestly like to get a really good, like a bench meter, to where I don't have to worry about batteries going dead. And let's see. Let's go ahead and clean this up a little with alcohol because I'm picky. So I don't have to worry about batteries going dead, and I can get the data communications to work and continue to work, and not have to fight with it. That's a little bit of a nuisance. I just want to make sure with all of our rubbery stuff that's here, I want to make sure that we don't have anything that's going to prevent my new cap from going down. I desperately need to clean the eyepieces on my microscope, so I actually cannot see it very well. Goals. Shop maintenance goals, people. All right, let's grab us a donor board. Oh, don't look at my burnt bench. You know, when I first got this bench, I didn't expect that I would keep it so long, and I didn't expect that when I first started posting videos that they would begin to get so much attention. I didn't expect all that. You know, had I known, I paid $20 for this bench. This was a $20 bench at a local closeout office place. I went and bought it, and I did what I do with any of my workbenches, and I use it as it's mine. If I need to drill a hole in it and mount a bracket to it, I drill a hole in it, mount a bracket to it. If I had realized that this was going to stick with me for so long and be a part of like a public broadcast show, I probably would have taken a little bit better care of it. But in the future, I'm either replacing the whole bench, or I'm going to cut this out and just replace this area, or I might just put something over it so I can uncover it once in a while, and then you can see where I came from. So let's grab us a donor board. Let's sit aside. Let's see, that is actually a known good board. I'll take you with me into my box of boards. All right. Now, what we've got here is everything on top here I can use for pretty much known good readings, a lot of it. And then everything on bottom is goo. Now, I will tell you, I have a shit ton of new parts in stock, but that cap, I do not. Let's see, that's like a 6S Plus. There is an iPhone 6 that has that cap still on it, right? We're going to take it off of this one. I also think for people that are doing touch IC repairs and wind up with no Wi-Fi after a touch repair that magically fixes itself later, I think this is the same cap at fault. Damn it. Every time I start to record a video, and think I'm going to plan something. And I'm here to tell you, it doesn't matter what I plan on recording. It never goes according to plan. You know, if I'm going to talk about something and I've got it in my head what I'm going to talk about, as soon as I press record on that camera, I'm serious like Garth Algar in Wayne's World. The first time that they're on the fake set with, what's the name of the company that buys them out? That's what I feel like. It's like in 3, 2, 1, and I'm like, oh, and I'm like all scared. That's what I feel like. Oh, this is horribly liquid damaged, guys. I'm not. Let me just show you. We're not going to take parts off of this. It is. Hungry. All right, so let's go after a different board. This one's not liquid damaged. Let's do this one. This one was just an iCloud board, and then I got really desperate for components, and it turned out being a test subject for a lot of things. All right, so let's see if we can get this stupid capacitor off of here. And I'm going to move on to my next repair after this boots. And I'm going to, you know, the long screw damage on this board, yeah, but I've been through enough of these boards. I guess I could dig in and like carve out the holes and see if there's anything to worry about. But I'm not worried about long screw damage causing no Wi-Fi unless that long screw damage has also caused no image, because those lines are going to get broken, typically broken first. And that's in the bottom left screw hole. The bottom right screw hole, I'm not concerned about long screw damage unless we have a phone that won't boot, because I2C0 typically gets cut first. So I don't feel like that's causing any issue. The long screw damage in the middle hole would typically cause a no image issue. So I'm not too worried about that long screw damage. You know, I'm not digging into fixing this stuff unless it's actually broken. Or I waste all that time trying to fix Wi-Fi just to spin it over here and find out that this goofy looking capacitor is shorted. So let's go ahead and get this goofy looking capacitor off the board. God help me, I don't have to stand up in my seat and get shocked in my damn earlobe. Ow! I laid my arm right on that hot board. I do like my new tool setup here, but one of the biggest problems I have with it is this big ass computer tower that's in the way. You can't see it, but I'm not moving stuff around. I'll screw up this whole video. You know, I've got my iron set up here. I've got my micro pencil, my mini hot tweezers, which I am gradually starting to love. And then I've got my larger 2027 handle, and I'm running all that off of the FM203 and the FX951. I'm running all three of them, and it's very handy. But in the future, whenever this stuff gets rearranged, I'm going to do this without my big computer tower on the desk, because that allows me to shift all this stuff over. So enough about my workspace. Let's finish fixing this phone, because I'm probably just as curious as you are. I want to know if this phone now has working Wi-Fi with this big crazy cap replaced. Okay, we're going to sit that. Now also, you'll notice that I'm no longer shielding Wi-Fi, and that's because I'm using leaded solder. Now I should have tinned this cap to be sure, but I know with leaded solder, that there's no way, solder. I know there is no way that I'm going to melt anything else before this leaded solder melts. The leaded solder will melt first, so I'm going to gently sit this down on the board. As it will melt first. I like to let them sit down under their own free will. That one just doesn't, I don't feel real good about that one. It might not be completely straight. And as you know, these things just won't work right unless they're absolutely, completely, totally, perfectly straight. You know what? It snaps back nice and pretty. Me recording a video, me nitpicking, me screwing with this, trying to make it straight, will destroy this entire phone. So we are going to just casually move on, while this board is still hot. I'm going to brush this up with some alcohol. Chip Quick Flux don't like to go anywhere whenever it's cold. I used to ultrasonic clean everything I put flux on because it makes a really nice looking board, but you just get so busy. You can't. You just don't make. You can't make time for all that. All right, so we'll blow my flux off of there. There we are. I'm shocked in my earlobe. Talk about a surprise. The first time it was like, oh, I hope that don't happen every time, and the second time it was like, pop, pop, pop. Shit. All right, one more look at that cap, guys. We got a little flux here and there. It's not bad. Not any worse than what Apple leaves on the board. We're not going to nitpick over that too much. All right, now the next step, I'm going to put this back into a housing. I'm actually going to put it back in this bent up, crazy looking housing. And I'm going to be sure and connect. And I didn't have a full screen assembly on this either. My first test, it got hot without a full screen, so I know it's nothing on the screen assembly. I should have checked to see if that line was shorted after I put the cap back, but pretty well certain if it's not shorted before I put the cap back, it's not going to be shorted after I put the cap back. Okay, and I am going to use the DC supply to boot this up. And the DC supply is on, it's set to 4.2 volts. I'm limited to 2 amps. We're going to make sure we get an Apple logo. And then I'm going to switch the camera off of that and onto me so that you don't get to see what's on the screen of this phone. And I'm hoping that this thing will boot up and have working Wi-Fi. We're currently drawing 200 milliamps. I'm pretty sure that's going to be the problem. I mean, maybe at some point in time after it booted up enough times with a failed Wi-Fi chip, it quits trying to enable it or something. I mean, I don't understand why I got so much heat. Like, it would burn you. It was alarmingly hot. It was too hot. I wonder if, maybe it burnt that inductor. I should have checked L5201RF. If this don't work, next we're going to go after L5201RF, because if this cap was shorted and causing a path to ground, I wonder. No, that should. I think the LDO here. This is a power. I'm not sure how this works. The phone's booted. I'm going to talk for a minute. I'm not sure how this works. I would think that LDO here. So this is VN. This is going to be a voltage input. So it could be that the power comes out of this VLX line and goes through this coil and then through the cap. And if that's the case, this little short here could have blown L5201RF. So let's see what this phone does. I am going to go ahead. I'm going to unlock the screen here. I'm going to open up settings. And then I'm going to make it so that you can see the screen. We're going to pull up Wi-Fi. And Wi-Fi is now enabled. So that means that L5201RF was not shorted. And we're not going to pick up anything either because my hotspots here are far away and I don't have an antenna in this phone. If I move the display off to the side, it will eventually get Wi-Fi service just from whatever reception it gets through the board itself. But gosh, for the sake of this video, I'm tempted to hold an antenna in it and just see if it'll show you all that this thing will get Wi-Fi service. Do I have an iPhone 6 antenna laying here? I sure thought that I did. What did I throw in here? Yeah, here's an iPhone 6 antenna. So here we go. Here's a Wi-Fi antenna. I'm not going to screw it down. I'm just going to try to lay it in here and hold down on it with my finger. And there we go. That's at least connecting the 5G antenna. I'm not sure about the 2.4 antenna. Let's turn it off. And we'll turn it back on. This should get both. Or neither. Am I really going to have to put screws in this to show that I'm not dumb? Wait till it refreshes again. There we go. So if I were to screw this antenna in, this would work. Now I'm going to go ahead. I'm going to hold down our power button. I'm going to slide the power off. Now this is a customer that after the last time I talked to them, I was about to give them bad news because when these Wi-Fi ICs are hard shorted like that on an iPhone 6, you take that combined with visible signs of long screw damage, combined with a housing, there goes my Wi-Fi antenna, that looks like this, you start to get to a situation where the appearance of this phone, it winds up being a no. But this one, I think, has dodged a few bullets, 3 bullets to be exact. I am going to go ahead, let's see, I'm going to turn my power supply off of this screen. I'm going to go ahead and call it into this video. I'm going to take this earphone out of my ear so that I can comfortably stand up off of my chair without getting shocked in my ear canal. So I do hope you all have successful repairs. I thank you for watching, and I will see you soon. Have a good day, everybody.